Our next part is going to be based on the simple conditional probabilities, like what exactly is conditional probability, how do we check independence of two events, or you can say, like, also sometimes referred also as Bayes theorem. So what I'm going to do is, first, the prerequisite for this particular unit is your basics of tree diagram. Now, tree diagram, we all know this is your assumed knowledge. So I'm just straight away giving a problem that can help us understand this concept. So consider that if it's, let's say, probability of being a dry day, assume that on any random selected day, here it is probability of dry day or rainy day. Probability of dry day, assume that it's 0.3, and probability of rainy day is 0.7. So if it is a dry day, let's say I go for cycling is 0.7 and I don't go for cycling is, let's say, 0.3. If probability of rainy day, if it is cycling or not cycling, so probability of cycling is 0.9, this is 0.1. So this is a tree diagram that, okay, one event is following the other event. Also, I'll just come back to this tree diagram. Also, let's say if there are problems about, like, marble removing, suppose that there are 3 red marbles and 5 green marbles in a bag. So what I'm going to do is, I'm going to pick up 2 marbles from here, one after other. So it's like, first you pick up one, you throw it out, and then you pick up the other. So this is without, this is also referred as without replacement. So how can I draw the tree diagram for this? So now when you try taking the first trial, it can be a red marble or a green marble. So probability of red marble is 3 out of 8. Probability of green marble is basically 5 out of 8. So the net probability, if you see on each branch, is basically adding up to 1. Also, if I pick up red or green again, now since I got a red marble on my first trial and I have thrown it out, now the chance of getting a red marble again, basically, if you look at, will be here 2 out of now 7, because now one red marble has reduced. So second is going to be 5 out of 7 is for green marble. While if I got first marble as a green marble, what happened is that probability of getting a red or green again. So let's say now if I got green as the first marble, my total greens are not changing. So here it's going to be 5 out of 7. Now why I'm doing 7 is because one of the marble has been removed earlier. Now since you got green on the first go, probability of getting green again will be 3 out of, this is going to be, red is 3 out of 7, sorry, this is going to be 3 out of 7, and this is going to be 4 out of 7. So since there were 5 greens, 1 green is gone, so we got 4 greens now, so 4 out of 7. Now, when you're doing the probability estimation, so let's say if you're finding out the probability of, in this case, now this was dry day and cycling event. So now remember that here cycling is depending upon the being dry day or rainy day. So when you're finding out the probability in this case, let's say I want to find a probability of cycling. Lots of times students just add the probability, they'll add a 0.7 with 0.9, and that's going to be wrong. Because this cycling event is purely depending upon the dry day or a wet day, or you can say rainy day. So when you're cycling, now cycling event is just not followed directly by these individual events. They are depending upon the dry day or a rainy day. So if I'm finding what's the probability of cycling, that's going to be 0.3 times 0.7, because it can be dry day or cycling and cycling, or it can be, so when there is an or, you add. So it will be rainy day, which is 0.7 times 0.9. So this is going to be the probability of cycling. Similarly, if I'm looking at here for the second event, where, like, okay, what's the probability of getting a red marble, exactly one red marble. Now exactly one red marble is in this category here, as well as in this category. So I'm going to write down, it can be red green or green red. So when it is red green, let's say the probability is going to be 3 out of 8 times 5 out of 7 plus, if it can be green red, it can be 5 on 8 times 3 out of 7. So firstly, these are the basic elements of the tree diagram. Now if I kind of take the simple condition on this now, what if you went for cycling? Let's say this is the probability for cycling. Now what if I ask that you went for cycling, I know that fact, what is the probability that on that day it was not raining? So here you imply the concept of condition. So if you see here, dry day and cycling, rainy day and cycling, so actually your cycling event is being decided by the nature of the day. So if I ask, given that you went for cycling, what is the probability that it was raining on that day? And this is referred as the conditional probability. So for conditional probability, we have a set formula. I just would like to kind of show this part. Now assume that this is a separate question. This is not related to this question. So suppose that this is football and basketball. There are 5, 3 and 2, which is maybe one outside. If I ask a random question that, okay, on from this event where there are in total 11 people, I'm picking one person randomly from, let's say, anywhere. What is the probability that that person plays a football? Let's say he plays the game that he plays is football. So straight away it will be 8 out of 11, because 5 plus 3, 8. 8 is the number of people that are playing football. So 8 out of 11. But now if I ask you a question that, okay, what is the probability that, okay, I'm picking up from people who play football. So people who are playing football, already I'm applying a condition on it. So who are the people who are playing football? These are the 8 people that you see. So these 8 people are playing football. Now from there I'm picking up. So my sample is no more a random sample. Now the sample became a conditioned sample. So what happened is that if I have to say this, given that is always represented by a vertical line, given that a person is picked up from people who play football, find out he also plays basketball. Given that a person is picked up from people who play football, which is 8 people, what is the probability that he also plays basketball? Obviously we can see that there are 3 people, these 3 center people are playing both these events. So these are my center point. These are the points who are, so answer is going to be 3 out of 8 here. Because what I'm going to do is, okay, I'm going to first pick up people who play football, and from there I'm going to see who plays basketball. So these are the people, like the 3 remaining people are playing basketball. So here what I'm looking is the intersection between 2 events. So as far as presentation is concerned, this is how you're going to present. This is how you're going to write down. But to write down the answer of this in a more structured way, I'm going to say, okay, this is going to be probability of basketball intersection with football upon probability of football, because that's my set that I'm looking at. So number of people who are playing football and basketball, there are 3, and number of people who are playing football is basically 8. So 3 out of 8 is the chance of, given that a person is playing football, he also plays basketball. So this is about implied condition, or you can say conditional probability. This is like a beginning of conditional probability. So when I'm representing a conditional probability or solving a conditional probability question, remember that you're going to first look at where are both the events occurring, and then divide by where the given event has occurred. Now what do you mean by this? Simply follow this formula. Intersection of first event with second upon probability of the second event which is given. So this is always written after slash. This is written because this is given and then this is occurring. So this is about the conditional probability. I'm just going to go back to this question now. So let's say I'll just first erase this part. Okay, so now let us say, I'm just framing a question here. What's the probability, let's say, what's the probability of being a dry day given that a person went for cycling? So let's say, given that a person went for cycling, what's the probability that it was a dry day? So dry day, given that the person went for cycling. So this is the probability that I'm looking forward to. So this is basically going to be probability of dry day intersection with cycling upon probability of cycling. So where do we see that it is a dry day and cycling? So dry day and cycling, if you see, is basically this branch, the first branch. So that's the dry day and cycling. And where do you see that other chance of cycling? This one, which is a rainy day and cycling. So dry day and cycling, so that's going to be, first chance is going to be 0.3 times 0.7. That goes to numerator. Upon probability of cycling, which we already done out here. So probability of cycling is 0.3 into 0.7 plus 0.7 plus 0.7 into 0.9. So this is going to be the answer for dry day and cycling upon probability of cycling, which is also referred as what is the probability of being a dry day given that the person went for cycling. So this is a simple probability question that is referred as a conditional probability. So here a lot of times the problem confusion happen is that how do we apply, which is given that, where do we write the equation? So remember that given that always comes second, and after that they ask you what's the probability of the variable that will come first. So if I would have asked, let's say, what is the probability that if a person went for cycling, what is the probability it was a rainy day? So simply, the person went for cycling, what is the probability of raining? So in that case, you look at rain and cycling. So instead of dry day, it will be rainy. Instead of this will be like 0.7 times cycling. So rainy day and cycling, which changes the numerator also. So 0.7 times 0.9 upon this probability, which is probability of cycling, which we already got. So this is a simple and clear example of conditional probability.